Welcome to Education Program Online with me, Teacher Christine, taking you in Mathematics for Senior 3 and Senior 4. So learners, our topic still remains real functions and limits. For today, we are going to look at what we call the limits, because the previous lessons we have been dwelling on functions. Therefore, today we are now going to look at the next concept, that is limits. So that is what we are going to look at today. So when we talk of a limit, what does it mean? So when somebody talks of limit, it comes from the word limitation, meaning that you are being blocked from reaching a certain goal or to reaching a certain point. So mathematically we say it simply means keeping a number or something in a fixed point. So when you are kept in one point, then you say I've been limited from achieving or going ahead, maybe because of certain issues. So in short, we simply say limits are like problems. You see, like a problem. So in math we say limit. In everyday life we say these are problems, because when you are faced with a problem, you find that you will not be able to achieve what you had planned for. So we say limits means keeping a number or something in a point. For instance, we say if function function f is a polynomial, such that fx equals to a base n times x raised to n plus a base n minus 1 times x raised to n minus 1 plus a base n minus 2 times x raised to n minus 2, and so on. Then lim of function f equals to function a x approaches to a. So this one we simply say it is read as the limit of a function f into x as x approaches x approaches a, is equals to f a. Take note of this. We say limbs occurs when x approaches a certain point. Certain points. So learners, let me explain this paragraph so that you can understand what we mean by limits. So we say the limits simply is the same as what we call the problems. And whenever the problems occurs, it affects you to achieve a certain goal that you have been, or to achieve your dream. So mathematically, we say limits simply mean that problem. We transfer it as limits in maths, meaning you are keeping a number or something in a point. You don't keeping a number or something in that particular point. That means you don't have a chance to move ahead. For instance, if we look at this, if a polynomial is expressed in this form, then this, assuming this is your dream, you have set up your dream that you want to achieve, and then from nowhere problems come. So we say lim of a function f will be, when x approaches to a, will be a function a, meaning that in this case lim when x approaches to a, when x is approaching to a, then there will be a change. There will be a change in a function, which is f. So when x is approaching to a, then we shall have lim of function x will equals to f a. This is simply means that looking at the relation, we said x and y move together. So anything that affects the x will automatically affect the y. So of which this will represent the y and this will represent the x. So you will always be able to refer your issue to the cause of that. That is what it means here. Now, NB, what you are supposed to take note is that limits do not occur just anyhow. It only occurs when x is approaching to a certain point. Let us assume like I have a child and I get a problem and I've been paying school fees for this child. So you find that when I'm being broken, or I've got a problem where I can no longer raise money, this child will not go to school. So she will always be referring that I'm not going to school because my mom has no money. So this is what it means. So let us look at how do we calculate the limits. One thing I need you to understand is that the value of x is what a here will refers, means or stands as any real number. It can be 0, it can be 1, any real number. So when x is approaching to any real number, the form or the rule, the relation that is set will also be affected. So let us look at it. Example. You say if fx equals to x plus 4, find a. Find a lim fx when x is approaching to 2, and then b, they say lim fx when x is approaching to negative 2, and then c, we have lim when x is approaching to 1. This is lim 3 of fx when x is approaching to 1. So, dear learners, when you look at this kind of equation, you need to understand that there are two ways that limits occur. Before a problem occurs, or before you fall into a problem, there is what we call always guidance. They will guide you. So when they guide you, the guidance will be for everyone who is within the group. But now, if you don't follow those guidance or those advice, then you will find yourself in a problem. So looking at it, when you are calculating limits, there is what we call before you fall into a problem and when you have fallen into a problem. Now when you look at it, example A, they say lim function x when x is approaching to 2. Then you simply say, if I'm to look at it, my formula or my solution, then I will have part A, lim of function x when x is approaching to 2 will now be my f. What is your f? Your f is given as fx is given as x plus 4. X plus 4. So you state your rule, that is x plus 4. Now when it becomes a lim, a problem, then you say it is lim x is approaching to 2. Meaning that instead of us again going to repeat this, we are now going to substitute x with what? With the 2, where x is approaching. Then now you will have x plus 4 is the same as 2 plus 4. And then your answer will be 6. So that is how you simply deal with the limits. Then when we come to part B, so part B, it says x is approaching to negative 1. So it will not make any difference. You know that where x is approaching is the value of x in the function. Then now you say I will have fx equals to x plus 4. And then when it becomes a lim, then you say lim x is approaching to negative 2. Then now you'll have x plus 4. It is at this level that you substitute. Then where there is 2 and x, you are going to substitute with negative 2. So you will have negative 2 plus 4, which will give us 2. So that is for part B. And then we come to part C. So part C, it says lim 3 fx, lim 3 fx. If you remember when I said that there are two ways, giving you advice before you fall into a problem, and then you ignoring the advice, and then you find yourself in a problem. So here, when you get a constant, after a limb, it means you have ignored the advice and now you are in a problem. So if you are to answer that one, then you come and say part C, I will have fx is given as x plus 4. Now when it comes to limb, when x is approaching to 1, we have x plus 4. What does it mean? Remember that there is a constant 3. So this means I will have 3 into what? Into the function x only. So this will be now, you only multiply the coefficient, sorry, the constant by x only. Because when they advise you that please don't do A, B, C, D, and then you go and do it, you will now regret to yourself alone of the problem that you have caused. So this 3, which is a constant, will only be affecting the x, because x now becomes a problem that you are in. So meaning that you will only regret to yourself, not the whole rule. So you will multiply 3 times the value of x, and our value of x is 1. So you will have 3 into 1 plus 4, which will give us 3 plus 4, giving us 7. So our answer is 7. So that is how you simply deal with the limits. And then let us look at example number 2, because we have seen when you are given advice and you ignore, you fall into a problem. And when you fall into a problem, you regret to yourself. So when it is a regret, you multiply the that is when you have a constant after a limit. A constant after a limit. So let us look at example 2. Example 2. Example 2 says if fx equals to x squared plus 5x minus 3, find a limb of x, function x, when x is approaching to -2. And then part B says limb fx when x is approaching to 0. And then part C, we have 2 limb fx when x is approaching to 1. When x is approaching to 1. So, learners, when you look at example number 2, it is of a quadratic. It is of a quadratic. Because when you look at the example 1, it was of linear. Because we are mostly basing on linear and a quadratic equations or quadratic functions. So, when you look at example 2, they have said if fx equals to x squared plus 5x minus 3, then find the limb of fx when x is approaching to 2. Then B, limb of fx when x is approaching to 0. And then C, 2 limb of fx when x is approaching to 1. So when you look at this, we come to our solution. You say, if I'm to state my solution or to answer question part A, then you first have to state the rule, that is the function given. So you say our function is x squared plus 5x minus 3. And therefore, if it comes to a limb, then I will have x approaches to what? To negative 2. And then our function is substituted as x squared plus 5x minus 3. Now in this level, this is where we are going to substitute the value of x. The value of x is negative 2. So where there is x, we are going to write negative 2. So we shall have negative 2 square plus 5 times negative 2 and then minus 3. So when we simplify this, we find that negative 2 times negative 2 gives us positive 4. And then 5 times negative 2, we get negative 10. And then we have negative 3. So with this, you will now find that when I simplify these negatives, I will get my result as 4 minus 13. So 4 minus 13. This will give us what? 4 minus 13, we get negative 9. We get negative 9. So that is the answer for part A. Then you come to part B. So part B, you also do the same. You state the rule first, which is x squared plus 5x minus 3. Then now you say limb x is approaching to 0. You substitute the function by x squared plus 5x minus 3. And then now from this level, you are going to substitute. You substitute what? You substitute x with 0. So when we are substituting x with 0, you say it is 0 square plus 5 times 0 minus 3. So 0 square will give us 0. And then 5 times 0, we get 0. And then minus 3. So our answer will be negative 3. So that is our answer. Then look at the exam part C of that question. So part C of the question is saying 2 limb fx when x is approaching to what? To 1. What does it mean? So this one, whenever you get a constant before a limb, it means in everyday life that it is the advice. When the advice are given, for example at school, you find teachers, especially in assembly, teachers tend to give you advice. It means the advice is given to everybody who is there. So it's now you to decide to take or you don't take. And if you don't take, then you'll be like the other part C of example 1. You'll regret for yourself. And then if it is like this, it means that this 2 is going to be multiplied. It's going to affect all the function given. So you say part C, fx is given as x squared plus 5x minus 3. So when it comes to limb, we say 2 limb of x when x is approaching to 1 is the same as 2 into the whole function. Are we together? That is 2 in a whole function. if it is before a constant before a lim, you multiply that constant by the whole function given. Then now when we substitute, we get 2. Our function is x squared plus 5x minus 3. And then now we know that x is approaching to 1. That means x is 1. So you will have 2 into 1 square plus 5 times 1 minus 3. So dear learners, in this case, before you open the bracket, make sure that what is inside the bracket is solved. What is inside in the bracket is simplified. Or you have solved the problem inside before you open the bracket. So you will have 1 raised to 2 is the same as 1. And then 5 times 1 it is 5. So we shall have 2 into 1 plus 5 minus 3, which will give us 6 minus 3, we get 3. So we shall have 2 into what? Into 3. It is at this level that we open the bracket. Then now you say 2 times 3 will give us 6. So this is your answer. So dear learners, that is how you play with the limits, especially when the functions are given. Don't know that there are always 2 types of equations, that is linear functions and quadratic functions. So we have seen all the examples on the 2 functions, and what I emphasize so much is that looking at finding the functions where x is approaching is the same as the value of x, that is the value of x when we are substituting. And then 2, take note, when the constant comes before a limit, what do? It affects the whole function. And when the constant comes after a limit, it will only affect the variable. That is what you are supposed to know. So with that, I hope you have picked something from these 2 examples on how to deal with the limits of linear and quadratic functions. So I want you to write this as your exercise. We say if fx equals to x squared plus 4x, this is minus 4x plus 8. Find a lim fx when x is approaching to 0, and then b, you have lim for fx when x is approaching to 1, and then c, we have lim fx when x is approaching to negative 3, and then d, we have 3 lim fx when x is approaching to 2. And then lastly we have e, which is lim fx when x is approaching to negative 1. So dear learners, take these examples, these questions, and study the examples very well before you answer them. With this, we have come to the end of our lesson now. And remember, we have been looking at limits and how to find the limits of both linear equations or linear functions and quadratic functions. That is what we have been looking at. With this, I can say goodbye for now.